In this video, I will show you how to fine-tune Llama 2 language model and how you can transform your dataset to Llama 2 prompt template. You will need a GPU to perform this task, but I will show you how you can use free Google Collab to fine-tune the model. So stick until the end of this video. First, we need the sharded version of Llama 2 model, and I am using this Hugging Face repo. You can use this as well in your code. So we are using AutoTrain library from Hugging Face, and with this library you can fine tune any model, either it is a language model or a computer vision model, right? So if you want to train this on your own machine, you need to download the AutoTrain advanced package from Hugging Face repo. All you need to do here is run pip install AutoTrain-advanced. You will need a Python version greater than 3.8 for this to work, and NVIDIA GPU in order to fine-tune a model. But here we are using free Google Colab, right? Okay, so let me show you how you can run this using a Google Colab. First, you need to go to the runtime, make sure that you are running the GPU runtime. After that, run the first cell. So this will install the AutoTrain advanced package as well as Hugging Face, Hub and dataset packages. Sometime you need to restart the runtime in order to use the packages. Alright, if you are fine-tuning the models on Google Colab, you need to include this line of code: AutoTrain setup --update torch. Otherwise it will not necessary for your local setup. Now in this cell you need to provide a Hugging Face token that you can get from the settings page and navigate to the access token tab. Just create a new one if you haven't created that already, and make sure to assign the right permission, as this will be required to push the dataset to the repo as well. Okay, just copy the token code from here and paste it in the cell and click the login button. You will see login successful. Now here is the dataset part. In this tutorial, I am using Open Assistant Guanaco dataset, but there are many good datasets available on Hugging Face like Dolly 15K that you can use as well. Now coming into the dataset that is not in our required format. As you can see, there are some tokens used in the dataset to segregate the user inputs and the model answers. But for fine-tuning Llama 2 model, we need the prompts according to the template provided in the Llama 2 paper. And the prompt template looks similar to this. There should be a system prompt, user prompt, and then model answer as well. So to tackle this requirement, I have added this code cell, and I am currently using only top 200 rows from the dataset, that is Open Assistant Guanaco dataset, in order to show you this tutorial, right? So you can see this code block will transform the prompts based on the tokens in the dataset. And later I need to log in the Hugging Face using CLI in order to push the dataset to the repo. So I will paste the exact access token that I copied previously in this cell again, and next it will ask me for permission to add the token as a git credential, which I will allow it, right? So now we need to push the dataset to our Hugging Face repo. Make sure you have already created a repo for dataset and provided the name in the code cell, right? After this code cell is executed, just go to your account in Hugging Face. You will see dataset rows will be available. And if you can go into dataset viewer page, you will actually see the prompts are now modified to our desired template. One thing I want you to note here is that you don't need to follow a specific prompt template if you are using the base Llama 2 model instead of that the chat version. Okay, the last code cell contains the fine-tuned code, and let me walk you through this code as well. First, write the AutoTrain keyword and then specify LLM, as we are fine-tuning the large language model. Include your project name here and then the model which we are already discussed earlier. Next, you need to provide the dataset path here, which will be the Hugging Face path of our dataset, which we have prepared specifically to train this model. Next, we use pipet. This means that full fine-tuning is not possible here. We use parameter efficient fine-tuning. This is the method proposed by Hugging Face, and now we are using it in 4 bits, so not using the full precision here. After that, there is a learning rate, which basically controls the speed of conversion during the training process. You can set it to a lower value so that it will take longer but converge better. The rest of the parameter you can set depending on the hardware you have. So you can set the train batch size. Since I am using Google Colab, so I have set the value of 2 for a smaller dataset. It depends on how many GPUs you have and the VRAM for each GPU. After that, we need to define the number of training epoch, which means how many times the dataset will pass from the model in training. I'm using 3, but again, depending on the dataset, you can modify it. Now the trainer that we are using is SFT. So this is a supervised fine tuning. As we are providing the dataset in input output format, right? And that's why we are using the SFT for the trainer. Next, we are defining the model max length. Llama 2 models have a context window of 4096 tokens. I am defining a much shorter context window in order to speed up the training process. Okay, if you want to push this to Hugging Face Hub to your own account so you can use this later, then you will need to provide the repo ID and you need to create a new repo in that case, right? I have already created one, so I included the ID of the repo here. Once the training is completed, you will see a config.json file as well as a tokenizer file and the model file in here in this folder. And then you can use the transformer library to load the tokenizer, the model, and do the inference or prediction on top of those. Since we enabled the pushing it to Hugging Face, so you will be able to see the model after a while, and again you can use the transformer package to download the model and start using it on your own local machine. So that's how you fine-tune a large language model on your own dataset using this powerful auto-train package. Let me reiterate, you will actually need a powerful GPU for this to work, because if you're running this on free Google Colab, it will probably take so much time unless you have very small dataset like I do. I have included the Google Colab notebook link in the description of this video. You can use this notebook if you don't have enough GPU memory in your system. So this is how you train Llama 2 large language model. If you learned something from this video, hit the like button and don't forget to subscribe. See you in the next one.